Hello, everybody. Welcome to another session of Me Programming Daily. Today on the agenda, drakon renderer. Again, let's switch to the code view. So during the last sessions, I've been working with this, let's call it an array that depicts the layout of all the paths to be balanced. And I think I'm pretty happy with the initial shape of the algorithm that detects icons to be shifted down. And off camera, I just prepared a little function that injects just integers into a list of lists of integers, just to sort of test the waters of how we could inject items into paths. So you see, if icon 6 is to be moved down, we need a function that will inject a valent point in its place, shifting everything below down. So I just wanted to establish like a reasonably easy to grasp and follow function that can be used for that. And you can see my experiments here. I'll show you the function in a little minute. But during my experiments, I came to a conclusion that in the end, it would be easier to represent the list of lists as the paths in the non-transposed fashion, meaning in the list of lists, each row would be a path, as opposed to each row being, like here, a markdown array row. It just makes injecting those icons arguably much easier. And the function that does it only takes a couple of lines. Well, when I say a couple, I mean 5. So we get an input list of lists of integers. I'm not experimenting with icons to be able to test it easily. You give it a row index, a column index, and a new value, and it returns an updated list of lists. It looks pretty elegant. We split rows by the row index, then we split the column by column index. We inject the new value. We append the old value just behind it and the remainder of the column that we were interested in. So for now, I'm just going to leave these abbreviations in. So the plan for today really is to put all of our findings together. Let's see what branch I am now on main. So let me just quickly create an issue. Or not, let's not create an issue. Let's be a little bit more creative. Or no, changing my mind again. What I wanted to do today is to put everything together that we've learned during the process of generating the markdown, injecting the icons, shifting icons around together. But before we do, I want to stop experimenting on this arguably very complex diagram. I want to start with something simple. So let's take it step by step. That's the way to go, I believe. So I hope everybody is having a great Friday and you all have a good plan for the weekend. I hope we all get to relax and spend some time with our friends and family. You know what? I might just borrow this branch. Or I'll do this. Close with comment. That way we should be able to start a new issue that will just be about creating a simplified diagram that needs balancing. And that will treat as the foundation for putting all of our learnings together. It's much easier to experiment on smaller diagrams. Let's start with something very simple. So now I can come up with something like that. Let's treat this as our blueprint. So what I would be interested in is a diagram that sort of looks like this, has a start, has a question, just one icon here, and the end here. Something very, very simple. Now here we'll have a little complication. 3 and 5, let's call it. 3 is going to be choice 1, and it's an action. Identifier 3, and it will lead to just one dependent, that is 4. Since this is an action, well, technically this could be the end. Yeah, let's make it very simple. So question 3 has one dependent, that's 4, and 4 is the end. And it doesn't have any dependencies. Dependence. However, there's just one more icon, and that's number 5. Oh, sorry. In that case, this could be 4 straight away, and that's the end. So just to make sure I'm not breaking anything, I'm going to comment out all those new invocations. And we're going to uncomment them out one by one. So paths, B paths, pretty markdown. We don't care. Let's build just to make sure it is working. It's not used, but that's fine. So finally, let's modify the run script. Okay, let's see what it did. Simple diagram layout. It doesn't look incorrect. Okay, I'm not sure if you can see this, but it generated correctly. We have the title, we have the question, we have the choice, and we have the end. So as we're balancing this graph, I'm expecting one valid point to be injected here. So this is a good enough start. That was a quick fix. Oh, this is already main. That's 116. Let's PR it quickly. Oh, we need to add it to a milestone. So everything is progressing nicely. We don't have to wait for a review here. And now a slightly bigger issue is incoming, and that is going to be to balance simple diagram. But can we think of something even smaller in scope? No, I can hardly think of anything smaller. That's self-explanatory. Let's remove main. Yeah. All right, so now we can check out a branch on which we will be balancing the simple diagram. And now, I hope this is where the fun part will begin. So we have paths. Let's try to print them. So these are the vanilla connections that exist for the diagram. Perfect. It's going to be much easier to work with. I can already see that. Here we'll probably only have two paths. 1 to 2 to 3 to 4, and 1 to 2 to 3. 1 to 2 to 4. Yeah. 1, 2, 3, 4, and 1, 2, 4. That's path number 1. Yep. 1, 2, 4. Now this is much simpler. Let's maybe not save it in the app, but rather in diagrams. Why Lua? Notes txt. Okay, this is good enough. Now, we know paths are working. Balanced paths we're not really interested in just yet. Now, this is where the slightly harder part starts. During my experiments, I mixed two things together when it comes to DC paths. Thing number 1 is rendering Markdown and all the emojis and all that good stuff that helps us troubleshoot problems. And the second thing is to determine whether valent points are needed and where, and determining how or which icons should be shifted. Now we need to detangle both of these problems. So what I'm thinking now is before we start generating this markdown that says, oh, we have an X here and X here, in order to make all the paths of equal length, let's skip that part. Let's take the paths as they are, even if they are of different length, and let's try to inject valent points wherever it makes sense. So the algorithm also will have to change, because you remember I transposed this list of lists in order to make it easier to work with. We've done it with a transposed list of lists. Now we have to re-implement it with an untransposed list of lists as you see it in front of you. So we go column by column first. And we have a lot of experience with that. Just by calling a function ABC. And now we can finally start using some types we have experience with. List of lists of icons. So the goal for now is to, just as an exercise, go through the list of lists and just for now, maybe form a new list that is going to contain information about whether icons match or not. So if we go row 1, icon 0 and icon 0 of both rows, the result will be true in the list. Icon index 1 and 1 in both rows, the value will be true because they are matching. Index 2, we see that icons are different. Therefore, for each icon, we'll have to check whether it is present further down the graph, and we will determine that 3 is not present further down the graph, so it will not be shifted, but 4 is. So 4 will be shifted, we'll be injecting a valent point in between 2 and 4, meaning here. Okay, so this is our first naive test with a simple diagram, and it seems to be working. So we go through all the rows and all the columns of our list of lists, and we want to produce a list of bools that illustrates whether icons under specific indices in every row match. So what I think would make sense is to go through all the columns first. But let's go slow. We want to return let's see. It looks like we'll have to use 2 maxes. Oh, sorry, or 2 counts. Or length. So I think we need to fold do max. So this function, I would expect to return 4. The condition for the number of columns will will most likely change as we progress. But for now, this is good enough just for testing. Oh, sorry. We should do this. Oh, so max just compares to numbers. Oh, so we fold again. Okay. So let's give this a name. Or do we do just this sort? There is a sort, but and this is in some package. Do we already have data list? Four, okay. So this is our now we can fold. So now we can go back to the return type and revise it. This is again single row. Can we just do this? No. Maybe we can. Oops, sorry. No, I do not want a dev kit. Thank you. That's fine. Let's not lose focus. And here we'll have to fold once again. But for now, Let's just test how it works. Step by step, we're not in a hurry. True, true, perfect. So now, now here we fold again. Over a list comprehension. We start, and now we're folding over. Oh, sorry. See, we started wrong already. We don't want to fold over rows. This is where you got to do. We want to fold over columns. So we fold over a list comprehension starting with 0, column identified by 0 index. And limit -1. So here we can't use R. This is column index. And now we fold over rows. Let's give it a full name, a row. And for this, we're just going to add going to return ACC to and just to make it a bit easier, I'm just going to return a sum for now. Of row indexed by the column index, ACC plus, and this is going to be a 0. So that here, that single number will be added to ACC1. So here we should expect one-dimensional list of sums of all icons. Now, this will most likely crash because we can't have column identified by 3 in the second row. So as a precaution, we'll just have to do this. If column index is greater or equal than, or length of row else 0. Oh, so here, this is not a number. So let's just be a bit cheeky and do this. Records. Get icon name. And here we get a double plus. Oh, this is what I was looking for. Thank you, HLint. I'm not tempted to remove brackets here. Two, 5, 9. Let's run it first. So we get 1, 1. Oh, and this is going to be in the reversed order. We don't necessarily want that because it just confuses me when I read. It's like in every function application, the collection is in a different order. I'm kind of tired of that, so let's do ACC1 plus plus, and we'll turn this into a list. Perfect. Now let's see if there is any H-lint feedback. This is not looking very pretty. I will keep that bracket and that one too. Move bracket. Oh, sorry, I can't read. Move brackets. And it is easier indeed. So for now, this is where we will draw the line today. Is I'm going to change the return type from a list of strings to a list of bools, and instead of just addition like that, let's see if we had. Perfect. So we're going to reuse this function. I knew it would come handy. So here we're just adding I'll simplify this a bit. If column index is lower than length of row, then ACC2 plus plus icon name else ACC2. And that way we're going to get a list of icon names, or maybe even icons. And that list we will this no longer has to be explicitly made into a list. just to make it build. So here we should do slice. So we're expecting true, true, false, true. False, false, true, false. It looks like it's inverted. Yes. No, it's everything is fine. Does not have multiple unique icons because it's 1-1. Does not have multiple unique icons because it's 2-2. Does have unique icons because it's 3, 4, and this one is only 4. But we'll never be applying this function to a set of rows of different lengths. So this condition where we only have one icon in all rows present is never going to be taking place, I think. So for now, I think this is a good indication to stop, and we'll be fleshing out this algorithm later by again taking a little bit of a step back to the issue we addressed the last time. To this. We started, you remember the algorithm was just determining, okay, we have different unique icons in a row. It means that some of them will have to be shifted. Now we have to determine which ones should be shifted. But we'll expand on this hopefully very soon. Let's just format we should probably have a slice function somewhere, but that's in a future iteration. Okay, I think that's good enough for now. I'm looking forward to the next session, but for now, looking at the time, we're running out. I thank you very much for sticking with me, and yeah, next session we'll be fleshing this out, and hopefully, if time allows and if we're lucky, we'll connect together all the pieces and we'll actually inject valence points. It's something that I decided to start doing automatically with rebalancing the whole graph, a week or 2 weeks ago? Feels like a long time ago. But it's fun. It's still a lot of fun to me. Right. Having said that, have a fantastic weekend ahead, and I'll see you next time.